Hello everyone, myself Birendra Rai, 21NS0-231 from Maths Department, 2nd Sem. I'm here in front of you all trying to discuss the topic L-C-R circuit. So let's begin. So firstly, let us discuss about the man behind the discovery of L-C-R circuit. L-C-R circuit was discovered at the early 19th century by two renowned and famous scientists, namely Alessandro Volta and Felix Savary. Now, let us discuss what L-C-R circuit actually means. So, I would like to explain it with help of a diagram. So, let me draw. So, this is the figure of L-C-R circuit. So, L-C-R circuit contains an inductor represented by L, a capacitor represented by C, a resistor represented by R, and a current is flowing through the entire circuit, and this is an AC source. Since inductor, capacitor and resistor are kept in series, so the current flowing through them three is same. So first, L in the circuit represents inductor. So the function of inductor in an L-C-R circuit is, first let us know what an inductor does. An inductor, it resists change in current flow, which means that if there is any fluctuation in the current flow, it controls it. So what basically inductor does is that it helps to stabilize L-C-R circuit. So the function of a capacitor is to store energy and to release it in a controlled manner. So in L-C-R circuit, what a capacitor does is that it helps in controlling the voltage or power that is applied to L-C-R circuit. So the function of the resistor is that it obstructs or limits the flow of electric current. So in L-C-R circuit, what resistor does is that it controls the flow of current. Now let us see derivation and calculation of L-C-R circuit. So first, let us draw L-C-R circuit. So this is inductor, this is capacitor, this is resistor. So this is AC source, voltage, and this is key This is the current flowing through the circuit. Figure L-C-R circuit. So already said by me, this is L, this is C, this is R, and this is I. Now let us consider L-C-R be inductor, capacitor and resistor connected in series combination. As you can see, L-C-R is connected in a series. And this is key, so key represents key. So when the key is closed, the current I is flowing through the L-C-R circuit. So this is V voltage. As you can see that the voltage in this circuit is split into three parts across L, C and R. So voltage across inductor will be minus L di by dt. Similarly, voltage across capacitor will be Q by C. Similarly, voltage across resistor will be IR. So now, to know the total voltage flowing through the circuit, we will be using Kirchhoff's voltage law. So now, according to Kirchhoff's voltage law, incoming voltage will be equal to outgoing voltage. So incoming voltage, which is V, will be equal to outgoing voltage. That means voltage through inductor plus voltage to capacitor plus voltage through resistor, or as we know that voltage across inductor is minus L di by dt, and voltage across capacitor is Q by C, and voltage across resistor is IR. So we will be putting the value over here. So V will be equal to minus L di by dt plus Q by C plus IR. So as we know that AC voltage V equals to V0 sin WT. So now replacing V by V0 sin omega t, we will get V0 sin omega t equals to L di by dt plus Q by C plus IR. So let this be equation number 1. So now we know that the current flowing through the circuit is I naught sine omega t. So let this be equation number 2. So now what we can do is that we can differentiate 2 with respect to t. So let's do differentiating equation number 2 with respect to t. What we get is that di with respect to dt equals to I naught omega cos w t. W is omega. So now again we know that current is dq by dt, rate of flow of charge, or just arranging it, what we get is dq equals to I dt. So let this be equation number 4. So from equation number 2 and 4, what we get is that dq equals to I naught sine omega t dt. Now what we have to do is that we have to integrate both the sides. So now integrating both the side, what we get, integrating dq, integrating I naught sine omega t dt. So now let's see what we get. So the integration of dq will be q. So integration of dq will be q, and integration of I naught sine omega t dt will be minus I naught by omega sine, integration of sine minus cos omega t. So integrating this we get this. So let us put this equation number 5. So now what we do is that we substitute the value of equation 2, 3 and 5 in equation 1. So let's do substituting equation 2, 3 and 5 in equation number 1. What we get? We get I forgot to mention one thing. Let this be equation number 3. So now what we get is that we get V naught sine omega t equals to L I naught W cos omega t minus I naught cos omega t plus I naught r sin omega t. So let's arrange or solve this equation. So what we can do is that omega t equals to I'm keeping this in front, I naught r sin omega t plus sorry, what we can do is that we can take I naught common. So taking I naught common, what we get, cos wt. Let this be equation number 6. So let this be equation number 6. We can further solve or simplify equation 6. So let's do. V naught sin omega t. So what we will do is that we will bring I naught to the left hand side. So it will be equals to r cos omega t. So let this be equation number 7. Now we know that impedance of an electrical circuit is Z equals to x square plus y square. So you all might be thinking what impedance is. So impedance is nothing but it is the total resistance of a circuit applied in the path of AC, that is alternating current. So what we can write is Z equals to under root x represents R, so y W minus L by WC square. So from this equation we get this. So now what we do is that we multiply and divide equation 7 by Z. So let's do multiplying and dividing by Z on equation 7. We get is that we get V naught sin omega t by I equals to Z by Z. See, we have multiplied and divided equation 7. So equation 7 is R sin omega t plus LW minus 1 by WC cos omega t. So now what we do is that we take this Z inside the bracket. So let's do V naught sin omega t by I equals to Z R by Z sin omega t plus y WC divided by Z cos W t. now let us take an assumption, which is let R by Z be cos theta and let by C divided by Z be sin theta. Therefore, let this be question number 8. So now, putting the value of R by Z in this in equation number 8, we get V0 sin omega t by I0 equals to Z cos theta sin omega t plus sin theta cos omega t. So from this we get V0 sin omega t by I0 equals to Z sin t plus theta. So let us consider this as equation number 9. So where theta is the phase angle. So as we know that V0 sin omega t is V, so replacing it with V, we get V by I0 equals to Z sin omega t plus theta. So now, further simplifying this equation, we get I0 Z sin omega t plus theta. So let this be equation number 10. So therefore, equation 10, this equation is called total voltage drop across series LCR circuit.